In this series, we'll move forward in the following order. Now, let's begin by looking at how the Bitcoin network works. As we've already discussed, the Bitcoin network operates through a unique form of majority consensus. Because the people and organizations running the software effectively participate in this consensus, it can be difficult to understand how the network behaves and how its development direction is decided. To understand the Bitcoin network, the first step is to understand the algorithm that drives it.
The Bitcoin network runs on a special kind of majority consensus. Even if the software is designed to enable decentralization, if a single person holds more than 51% of the decision-making power, the network wouldn't really be decentralized. That said, the algorithm itself always follows predefined rules, so it's a great starting point for understanding this complex system. Once you understand that and then learn about the people and organizations running and developing the software, you'll start to see things much more clearly.
Before we go into the details of the Bitcoin algorithm, let's go over some key terms. There are 3 terms that will come up frequently. A transaction is data that represents the transfer of value. Who is sending how much to whom? It's the most commonly exchanged data in the Bitcoin network. A block is a bundle of transactions collected over roughly 10 minutes. And the blockchain is a chain of these blocks, each linked to the previous one. These blocks are connected using cryptographic techniques called hashes, which make it extremely difficult to alter past data. Full nodes store the entire blockchain. In other words, they keep a record of every block and every transaction. Among full nodes, there are mining nodes that compete to validate transactions and earn Bitcoin, and non-mining nodes that simply relay transactions and blocks.
The term mining originally comes from extracting resources like gold. In Bitcoin, it's similar to those who win the competition earn Bitcoin. These days, mining requires specialized hardware to stay competitive, so only a subset of full node operators actually mine.
First, let's take a look at how digital payments work. By understanding this, it becomes much easier to see what makes Bitcoin unique. Let's say you buy a beer at a convenience store using digital payments. You tap your smartphone, hear a beep, and the payment is done. So what's actually happening behind the scenes? Your payment app sends transaction data to the company's server. The server then updates its records, reducing your balance by $3 and increasing the store's balance by $3. Every time a transaction happens, the server repeats this process and keeps updating the records. In this kind of system, a specific company sits at the center and manages everything. It keeps track of who owns how much and what transactions have taken place.
If you're an engineer, this structure is easy to understand. Even if you're not, you can probably imagine how it works.
As we saw, software-based payments are usually managed by a central party, like a bank or a payment service provider. But Bitcoin works differently. Even without a central authority, many computers coordinate, communicate, and process transactions together. This is why it's called decentralization. To make this possible, all full nodes store the entire history of transactions in a structure called the blockchain.
Isn't that kind of amazing? There's no leader, and yet everything keeps running smoothly as everyone works together. In this series, we'll take a closer look at what decentralization really means.
In the past, it was believed that a system like this wouldn't work. The main issue was something called double spending. Double spending means using the same money twice. For example, imagine you only have $1,000. At the same time, you send one transaction saying, "I'll send you $1,000 to buy a computer," and another saying, "I'll send you $1,000 to buy clothes." If both go through, you would end up getting both items, even though you only had $1,000. In a traditional payment system, this isn't a problem. The server processes transactions in order, and only the first one is accepted. But in a decentralized network like Bitcoin, There's no central authority to make that decision.
In a normal system, everything goes to one place, so it's easy to decide based on order. That part feels pretty intuitive, right? But with Bitcoin, there's no single place where transactions are sent, so you might wonder, where do they go and how do they get confirmed? Let's take a look.
First, the sender obtains the recipient's address and creates a transaction using a wallet attached to a full node. Up to this point, it works just like digital payments. Next, the transaction is sent to a connected full node. The receiving node verifies the transaction, and if it's valid, relays it to other nodes. In this way, the transaction is passed along from node to node and spreads throughout the network. Because people initiate transactions from many different places, transaction data spreads outward from many different nodes across the network, like ripples. Miners collect transactions over about 10 minutes and bundle them into a block. They then compete to solve a mathematical puzzle that combines this block with the blockchain data, which contains the accumulated record of past transactions. The first miner to solve it earns Bitcoin. So they compete using large amounts of electricity. The successful miner includes their reward and broadcasts the newly found block across the network in the same way that transactions are propagated. Finally, all full nodes add the block to their own copy of the blockchain.
Can you picture it? All nodes end up holding the same history of transactions. In traditional systems, transaction data is stored in one place, but here, every node holds the full history. It might look inefficient, but it's necessary to achieve decentralization.
Sometimes, two miners find different blocks at nearly the same time. Each miner broadcasts their own block, and nodes that receive both discovered blocks split the blockchain and connect both. When the next miner successfully mines a block and propagates it, nodes that receive it connect to the block they can extend. As blocks are added in this way, the rule is that the chain that ultimately continues longer is regarded as the valid blockchain. As this process continues, miners have an incentive to build on the chain that will remain the winner, so all miners gradually converge on extending the same chain.
Having the same transaction history across all nodes is extremely important. Otherwise, you'd run into problems like, was the payment made or not? This was Satoshi's key idea, creating a shared, consistent transaction history in a decentralized network. Can you picture how even in a leaderless network that anyone can freely join or leave, and where transactions start independently in many different places, one shared set of approved past transaction records keeps being formed?
So far, we've seen how the Bitcoin network operates in a decentralized way. Now let's look at development and upgrades. These are also handled in a decentralized way, and this is a very important point.
If someone could control upgrades, they could change the system to benefit themselves. In other words, it's not just Bitcoin issuance and transaction validation that need to be decentralized. Development and upgrades must also be carried out in a decentralized way. Only then can the network truly maintain its decentralized nature.
Bitcoin Core is developed on GitHub, and anyone can participate. As long as the license is followed, modified versions can also be used.
Because it's open source, anyone can inspect the code and propose improvements. Bitcoin is a protocol, a set of rules. As long as you follow those rules, you can communicate with other nodes. However, for the parts related to consensus, using a single implementation is generally recommended to reduce the risk of issues. That said, it's still possible to propose improvements to that part.
The actual development activity can be seen on the GitHub project page. There's a contributor list that shows how many people are involved.
I love that. It really feels like money created by everyone. As an engineer, I'd love to contribute someday.
Upgrades are also decentralized. When it comes to development direction, if agreement cannot be reached, the system is designed so that Bitcoin can split into two.
A well-known example is the split that created Bitcoin Cash. At the time, the number of Bitcoin users was gradually increasing, and as transactions grew, fees sometimes rose significantly. This led to disagreements over the future direction of the network. Some argued that the block size limit should be increased to include more transactions in each block. Others believed that keeping blocks small was essential for decentralization and should be preserved. Because these views could not be reconciled, the network split into two. Neither side was necessarily wrong, so the debate involved the entire community and required a great deal of effort. I actually think this mechanism is good because it allows minority groups to continue their own vision.
There are various ways to implement upgrades, and they can be difficult to understand. So here we'll look at just one simplified example. Let's say miners are currently using a certain version of Bitcoin Core, and a new version is proposed that includes updated consensus rules. Miners who agree with a change to the consensus rules start mining using the new version of the software. For a certain period of time, when they successfully mine a block using this version, a signal indicating support for the new version is included in the block. As more miners support the new consensus rules, the proportion of blocks signaling support for the update gradually increases. After some time has passed, if a majority of miners are signaling support, the update is activated. Once the update is activated, blocks begin to be produced according to the new consensus rules. To avoid wasting energy, the remaining miners also update to the new version.
There are many upgrade methods, so this is just a simplified example. The key idea is that whether an update is accepted depends on majority support. There are also approaches where non-mining nodes take the lead, and these have influenced miner behavior in the past.
In this way, even rule changes are handled in a decentralized manner. This is a core feature of Bitcoin.
We've taken a look at decentralization in Bitcoin. Unlike traditional digital payment systems, both the creation of money and the validation of transactions are decided without a central authority through a form of majority consensus. That's what makes it so interesting. Upgrades are also carried out in a decentralized way. This is a very important point. When people ask what Bitcoin is, there are many different answers. Some people describe it as something like a language. Under a shared set of rules, the software you run can communicate with software run by others. There's no central leader, and it's distributed all around the world. For example, when someone creates a new word and more people start using it, that word can eventually become part of the standard language. Some people see Bitcoin in a similar way. In many countries, people are not allowed to freely create money. But Bitcoin introduced a system where people collectively create money and exchange it with one another. It has spread in part because there's no clear single point of control. It's not obvious who you would need to stop it. In the early days of the Bitcoin network, developers were also node operators, miners, and users sending and receiving Bitcoin. As Bitcoin's market capitalization grew and more participants joined, roles became more specialized and separated. Mining, in particular, has become dominated by large-scale operations, since mining at scale has advantages and requires significant capital. We didn't cover mining pools here, but in order to compete effectively, miners form groups and work together to mine. There are concerns that as individuals and organizations with strong influence emerge, the concentration of mining could make it difficult to maintain decentralization. At the same time, approaches like UASF, where upgrades are driven by users, are being explored, and affordable mining kits that allow individuals to mine at home are widely available. Because of this, the idea of decentralization is still strongly embedded in the design of the Bitcoin network. The direction of upgrades is also decided through a form of majority consensus, so no one can clearly predict the future. But personally, I think the mechanism of decentralization is remarkable, and I'm strongly drawn to the idea of money created by everyone.
As we've seen, the Bitcoin network operates without a central leader. Everyone works together to generate Bitcoin and process transactions. Even upgrades are decided through a consensus-like process. Hopefully, the reason it is called decentralized is now clear.
We've gone through how Bitcoin works. It's often said to be difficult to understand, but this is the first step. I'd be really happy if more people became part of the Bitcoin network.